Okay, now we're going to look at the equation y equals a cosine bx. We've done the sine graphs, we haven't done the cosine graph. Cosine graph is similar to the sine graph in that we again note that we have a and b. So if we want to graph y equals the cosine of x, here we note that a would equal 1 because there's no number in front of the cosine. It's understood to be a 1. And b would equal 1 because there is nothing in front of the x, so it's understood to be a 1. We do the same thing with the period. So the period is going to be always 2 pi over b, which is equal to 2 pi over 1, which is 2 pi. So we know when we graph, we're going to start at 0, and we're going to go to 2 pi. And again, if we break that into quarters, we have pi, and here we have pi over 2, and here we have 3 pi over 2. We have the point 1 and negative 1. So if we start to determine what this graph would look like, we're going to start with 0. So if x equals 0, we have y equals the cosine of 0 degrees, which is, cosine of 0 is 1. So note that at x equals 0, the cosine starts at the point 1, not at 0. That's the big point. That's the big difference between this and the sine graph. When it starts at 1, when it's 0, you know that it's a cosine and not a sine. The sine always starts at 0. Let's go to pi over 2. If x equals pi over 2, substitute into our equation, y equals the cosine of pi over 2. And what is the cosine of 90 or pi over 2? It's 0. So pi over 2 is 0. Let's try x equals pi. Y would equal cosine of pi, and the cosine of pi is negative 1. So we go down to negative 1. Now let's do x equals 3 pi over 2. And again, we're just trying each of these values listed below. We would have y equals the cosine of 3 pi over 2, or 270, and the cosine of 270 is 0. So at 3 pi over 2, we're at 0. Lastly, we try x equals 2 pi into the equation. Y would equal the cosine of 2 pi, which we know is equal to 1. So at 2 pi, we will be at 1. And then we just draw our graph from beginning to end, and you see the cosine graph looks like this over one period. Remember that it keeps going on both sides, so this does keep extending and this does extend and go back down again, but one period. What do we mean by that? Well, it starts, here's a starting point, and if you look, it's going down, 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 up, 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 but it starts repeating right here again. So it went from 0 to 2 pi before it started repeating again. That's why the period is 2 pi here. So this is the graph of our cosine. Now, it's the same thing with your a's. If we add an a where y equals 2 cosine of x, same thing as this graph, except we don't even have to do the math. The same places where the graph is at 0 will be true for this graph, here and here. What difference will we have? Well, if a equals 2, our graph will go, instead of at 1, it will go up to 2. And instead of negative 1, it will go down to 2. Instead of 1, it will go up to 2. So the graph of y equals 2 cosine x is going to look like this. And do you see how the amplitude is stretching it higher? That's a. What happens if a equals 1/2? Y equals 1/2 cosine x. What would that look like? Same exact graph as what we have here, because remember, b has not changed in any of these. B is 1. So our period is 0 to 2 pi regardless. The only thing we're doing is changing the a, and the a is the amplitude. So my zeros will be at the same place that they always are, here and here. But where I have a 1, I will change it to 1/2. And where I have a -1, I will change to -1/2. And again, where I have a 1, I will change to 1/2. So my graph here is going to look like this. And that is the graph of y equals 1/2 cosine x. Notice it's brought it down, shrunk it length up and down. That's the graph of the cosine. Things to note about the cosine is that it starts at 0 at 1. That helps you tell if you're looking at a sine graph or a cosine graph. So this is done the same way as the sine graphs. And it's the same thing if we change b that we did in the sine graph. So hopefully you can follow this example and you'll be able to graph your basic sine and cosine curves.